Previous videos, we saw how to evaluate classification models. Well, we made it look fairly simple, but in this video, we're going to look at some real-world scenarios that show that things might not be so simple in making actual organizational decisions. So our first scenario here concerns medical diagnosis. So consider that a scenario where you have two different medical tests available for a new serious sickness, like in the COVID-19 pandemic, you have PCR tests and you have antigenic tests for COVID-19. Well, suppose test A correctly identifies 95% of sick people, but it wrongly signals that 30% of healthy people are sick. But then test B correctly identifies 70% of sick people, so not as many as test A, but it wrongly signals 5% of healthy people as sick. So in other words, it doesn't correctly identify as many sick people, but it's much less likely to say that someone who is healthy is sick. So the question is, which test should you take if you have the choice? And this might depend on if you have symptoms. If you're exhibiting symptoms, which test is better to take? But then which test should you take if you don't have any symptoms, but you just want to make sure that you're not sick? So you have these classification results. What decision do you make? I'm not going to answer these questions directly. In subsequent videos, these matters will unfold as we see different issues when deciding classification scenarios. Here's another scenario with bank marketing. So in this scenario, there's a bank that has done some analysis on a data set of past customers, and they're trying to launch a marketing campaign, and they might decide to or they might decide to contact customers by email, by postal mail letters, physical letters, or by telephone calls. Understand that email costs almost nothing. Postal mail is fairly cheap, maybe €1 per letter, and telephone calls take some time. They could cost 5 to 10 euros per call, depending on how long the agent is with a customer. So these are different expenses. And this organization does an analysis, maybe with a classification decision tree, to identify which kinds of customers indicate have responded positively in the past or not. And with this information, what strategy should the organization follow with a decision tree like this? So in this, very briefly, you have some customers high income, some high or low education, some with of large or small families. When you have results like this, what strategy ultimately should you follow? Okay, another example. So here we're looking at what I would call extreme events. So extreme events have two main characteristics. One is they're very rare. Very rare means less than 1 in 1,000. It's not just like 1 out of 10, but it's less than 1 in 1,000, 1 in 10,000, 1 in 100,000. So that's why it's extreme. It's something that does not occur very often. Yet it is very important, and its consequence is very severe. Unfortunately, it's almost always very negative. For example, the consequences might be someone's death. It might be a matter of, so in other words, maybe identifying a deadly disease. If you miss the symptoms, someone might die. It might be terrorism. I mean, there's hundreds of millions of people, but maybe only one of them is a terrorist. But if you miss that, then that could cause a lot of deaths and also economic damage. It might be something that leads to major financial loss. So maybe a major case of fraud in an organization. Very rare, but could cost millions of euros if undetected. So these are what are called extreme events. They're very rare, but when they happen, the consequences are quite severe, usually negative. And the implication is that false negatives are intolerable. A false negative is when an algorithm does its analysis and says these cases are not what you're looking for, but actually they are. So the algorithm missed those cases. And you just can't tolerate that in these kind of scenarios. And that's the nature of extreme events. However, rather than doing classification problems such as using logistic regression or using a classification decision tree, these should be taken as outlier analysis problems. That is, it's not just you're trying to find as many correct answers as possible. You want to find every single one, and it doesn't matter if you get a lot of mistaken cases along with it. You want to cast a wide net and catch maybe in the case of cancer screening, you want to catch maybe 10 times as many people who are likely to have cancer so they can find that one person. You want to screen 100 people so they can find that one terrorist or so on. And I gave the example of terrorism, but it's not always necessarily like that. Airport screening, actually, far more common is things like smuggling of maybe alcohol or tobacco or drugs. That's far more common, and so that's closer to the 1 in 1,000, which is still important for the organization to find. Um, so the key here is that it is acceptable to find a lot of false positives that are not actually the case, as long as you don't miss any uh, true positives. Now, the focus of the videos that follow are on regular classification, not outlier analysis. So I'm explaining the nature of extreme events so that you understand that this is not what we're treating, because a lot of times people lump this kind of problem together. But the point here that these are not, or these should not be treated as classification problems, even though they often are. They should be treated as outlier analysis problems. And here's a link to a video or link to some documentation that explains in more detail how to how classification algorithms can be used for imbalanced data sets, and that can be applied more probably for this kind of outlier analysis. So going on, to understand how to address these kind of problems that I've brought up here, let's look at the differences between regression in machine learning versus classification. Now, in regression, you're trying to predict a number versus classification where you're trying to predict a category. In regression, you want the closest possible estimate, and you know you'll never get exactly like trying to predict the amount of sales that you're going to get, or the exact number of customers, or the exact temperature, or so on. But closer estimates are more valuable. So this is like target shooting, where there's concentric rings, and although none of them here hit the bullseye, well, the ones that are closer are more valuable. They have higher points. That's kind of like what regression evaluation involves. The closer you are, the more credits you get. However, in the classical approach to classification, it's all or nothing. For instance, does that customer buy or not? Does the customer leave our does the employee leave our company or not? It's not they almost left or not. No, you're trying to know black and white, definitely did they or did they not. And so this is like target shooting, where either you hit the target or you don't. If you hit it near the edge, well, you hit it. If you just barely missed, well, that doesn't mean much either. Okay, so close does not count. But why not? Real life doesn't have to be so black and white, because why does 50-50 have to be a strict cutoff? So well, the example, a customer that's almost bought versus one who actually bought, or well, it's close, but perhaps what you learn from the one that almost bought can help you to help other customers that are on the edge and tip them over to bot. So just doing black and white classification loses a lot of valuable information. And so we're going to look in subsequent videos on how to be more nuanced about our considerations here. So from these perspectives, this gives us a roadmap that we're going to follow of basic classification strategies. So first, if you have an extreme event, you're trying to find someone is a terrorist or not, if this is a fraudulent transaction or not, if it's a rare event, well, outlier analysis techniques are more appropriate rather than the classification techniques that we're going to cover. Then for all legitimate classification problems, we're going to see that we need a lot of subjectivity. That is a lot of managerial discretion. And we're mainly going to look at sensitivity and specificity, or precision and recall as the specific measures with subjective judgment. We're also going to see how to make decisions with lift charts, which give very actionable prioritizations of which cases to take priority action on. Another approach, an important approach that we're going to see is in cases where you have revenues and costs that are clearly quantifiable. For example, you can actually convert them to euro amounts, then cost sensitive scoring is an important, very valuable approach. And this is distinct from cases like when you're trying to see are people going to get cancer or not. You can't put a euro value to people's health. So cost sensitive scoring doesn't work. But if you can meaningfully convert what you're looking at to euros, then this is a helpful approach. This is what we're going to see in subsequent videos.